Well, hey there, trigonometry class. I'm sorry I couldn't be there today. I miss each and every one of you. But this is going to be fun. We're going to do a video here, and I think you're going to like it, and I'm guessing you're going to ask me to do more of these. Because you're sitting at home right now in your pajamas on a comfy couch or something like that, and this is way better than coming to class and sitting in an uncomfortable chair in clothing that is less comfortable than pajamas. For the record, I won't kick you out of class if you're wearing pajamas. But anyway, let's get to the examples. I want to do number 62 in section 10.8. A boat leaves the marina and sails 6 miles north and 2 miles northeast. How far from the marina is the boat, and in what direction must it sail to head directly back to the marina? Okay, so quick picture. You got your marina right here. The boat travels exactly 6 miles north and then 2 miles northeast. The first way I want to do this problem is I want to do it using a triangle, kind of the old-fashioned way. We can call this angle A, B, C. And right off the bat, we know that we're given two sides. You can sort of split this angle up into two pieces. You know that this is a 90-degree angle if you draw a straight horizontal line here. And what angle is this? Well, the problem says that the boat is sailing northeast, which implies a 45-degree angle. So we have a 90-degree angle plus a 45-degree angle. That's a 135-degree angle right there between the side of length 6 and the side of length 2. Answering the question is going to involve solving the triangle. This is a side angle side triangle, so we can use the law of cosine. So I wrote down my law of cosines. I plugged in A and C and the angle B. Okay, I asked Google what the answer was, and Google said 7.548 miles. Now, I want to find maybe angle A to answer the other question. In what direction must the boat sail back to get back to the marina? So I'm going to use the law of cosines again, the version of the law of cosines that has the angle A in it. There we go. I plugged in all of my information. I'm going to ask Google what this number is. Okay, now keep in mind that very slight changes in the rounding that you do early in this problem can change the angles that you get here pretty drastically. So make sure you take a lot of decimal places. In fact, my answer could be off by a tenth or two because I rounded to 7.548 and didn't take more decimal places. But we'll take this as correct and answer the final question. So if we say that this angle right here was 10.8 degrees, then if we take a look at where our boat is right now and draw a line straight south, that angle there is also 10.8 degrees. So the easiest way to answer this question is to say that the boat should travel 10.8 degrees west of south. And if the boat travels in that direction for 7.548 miles, you should get right back to where you started. Okay, I want to do this problem all over again, except this time I want to use vectors. And please don't just tune this version of the problem out, because there are going to be problems pretty soon that we have to use vectors to do. Okay, again, our boat starts here. It's going to sail directly north, and then it's going to sail northeast. I'm going to call this vector, say, U, and I'll call this vector here V. And now U is pretty easy to figure out because it's sailing directly north 6 miles. So there should be no x component of that vector. The vector is not going left and right. It's going straight up, and its length is 6, so it makes sense that that is going to be our vector u. The vector v might be a little bit trickier because it has both an x and a y component. If you think about something going northeast, again, this angle here is going to be 45 degrees. Well, that is the angle associated with the vector because that is the angle that the vector makes with the positive x-axis, say. And remember in class when I told you that any vector, if we have its magnitude and its direction angle, can be written like this? Well, we're going to use that because we know the magnitude of this vector is 2, because that's how far the boats sail, and we know its direction angle is 45 degrees. So v is going to be 2 cosine of 45 as the x component, and the y component is going to be 2 sine of 45 degrees. We know that cosine of 45 degrees and sine of 45 degrees is the square root of 2 over 2. The 2's cancel, so we know that our vector v is just root 2, root 2. The question we can ask is, what is the resultant vector? That is just going to be the vector u plus v.
Square root 2 is approximately 1.414.
If I add u and v together, I get this result right here. If we plug it into our calculator, we get an approximation, which appears right here. Now, how do we find the length of this blue vector, this resultant vector right here? Well, we take its magnitude. We square each component, add them together, and take a big square root. Plug that into your calculator, you get yourself an approximation, of course. And I sure hope that that's the answer that we got doing it using the triangles. Okay, so how do we find something out about the angle with which the boat has to travel home? Well, this u plus v vector is this blue vector right here, of course. And we can find its direction angle pretty easily. That's that angle right there. Using that whole tangent of the direction angle is the y component divided by the x component. We learned that trick in class. If we plug our y component and our x component into that formula that we learned in class, we get this equation right here. We can take an arctangent of this result right here, and we get the angle is 79.2 degrees. Okay, so that's the angle of the vector from the horizontal right here. But what we really wanted, we learned in the last example, is that angle right there. So since this vertical u vector and this horizontal that we drew in is 90 degrees, that leaves 10.8 degrees in that angle right there. And I think you'll see that that's the exact answer that we came up with using triangles, and we could finish the problem the exact same way. Okay, we spent enough time on this example. Let's look to the next one. Number 64 in the same section says, a woman starts walking from home and walks 4 miles east, 7 miles southeast, 6 miles south, 5 miles southwest, and 3 miles east. She's a wanderer. How far has she walked? And if she walked straight home, how far would she have to walk? Well, how far has she walked, I guess, is pretty easy, I'm assuming. It's just 4 plus 7 plus 6 plus 5 plus 3. I'll let you do that one. But if she walks straight home, how far would she have to walk is a more complicated problem because she's going every which way here. I'm going to draw a quick picture of the scenario. All right, there's my drawing of the overhead map of where this woman has walked. And as you can see, drawing 5 triangles or 6 triangles or whatever it would be is not going to be a convenient thing. So vectors is the way to do this problem. I'm going to call the vectors u, v, w, a, and b. I'm going to write down each vector over here. If we add all of those vectors together, we are going to get this resultant vector right there from where she starts to where she finishes. And then we can solve the problem by finding the magnitude of that vector. Let's do it. Okay, u should be an easy one. You're walking straight in the positive x direction. No y component for 4 miles. W should be an easy one. You're walking straight south. You have no x component, and your y component should be negative, but you should have a magnitude of 6. B should be an easy one as well. 3, 0 in this case. The angle V has an angle right here that it makes with the positive x-axis. That happens to be negative 45 degrees. You could also call it 315 degrees, and that would be fine. So the vector v is going to be the magnitude times the cosine of that angle in the x component, and in the y component, the magnitude times the sine of that angle. All right, what is the angle of the vector A? You could call it negative 135 degrees, or you could call it, let's see, 180 would be a straight line plus 45, 225 degrees. I'll use 225. And that makes our vector 5 cosine of 225 and 5 sine of 225. Again, in each case, I'm finding the angle that the vector makes with the positive x-axis, from straight east, in other words. Okay, I plugged in what the cosine and sine of negative 45 degrees as well as 225 degrees were, and I got these exact answers for those two vectors. Now what happens if we add all of this stuff up? 4 plus 7 square root of 2 over 2 minus 5 square root of 2 over 2 plus 3.
The answer is approximately 8.414.
Okay, I Googled it, and this is the resultant that Google gave me. I should really have a sponsorship with Google. And the question asks, if she walks straight home, how far would she have to walk? Well, that's just the magnitude of that resultant vector. All right, Google tells me that the answer to this problem is 16.75 miles approximately, and I trust it because it passes the sanity check. These two vectors came out to approximately what I expected, and this seems about right as well. So I'm going to box that bad boy up. All right, guess what? You guys get a take-home quiz. This is the video quiz. Do section 10.8, number 63. It's very similar to the last example we just did. I know that the answer is in the back of the book, but you don't even know if that thing's right anyway. But either way, show all of your work clearly, and that's the only way I'm giving you all the points. Okay, write all that down on your own piece of paper and bring it to class on Monday. Okay, that was fun. I'll see you all on Monday.